Okay, so this is our second video for transformations. So we are on to translations. And I'm telling you, by the fourth video, this will get easier. You kind of pick and choose what you do. But for now, we have a reflection or a flip over the x or y axis. So we have the x or the y. Now, just like translations, we have to think about the positioning of our negatives signs. So for the reflection over the x-axis, we have a negative on the outside. So we have our parent function, and we apply a negative sign to the outside. And eventually that'll look like distribution. So we have our parent function for the y-axis, and the negative sign is applied to the inside, which means it's stuck right with x. And it always flips right at that point where it crosses that specific axis. So we're going to go down here. We have our parent function, 1/2 x plus 1. Okay, we're graphing a negative function, and that negative sign is on the outside, so we have to say this is a reflection of the x-axis. Okay, so I took our x's, -1, 0, and 1, and I plugged it into our parent function f of x. And I got 0.51 and 1.5. Okay, but I'm also going to show you how to graph using our point slope form. Our m and our b, our m is 1/2, our b is 1, so yep, our y-intercept is 1. Then we're going to go up 1, right 2, up 1, right 2, and you see that that 1/2 and 1/2 line up perfectly. Okay, so you can use a table, or you can use your slope and your y-intercept. So now we're applying a negative to the whole function. So what we have to do is either take a negative to each of these points, which would be -0.5, -1, and -1.5, or we can apply a negative to our whole function. Okay, and that just flips the sign. So now we have -1/2 x minus 1. So if we plug in 0 here, like we did above, we are going to get that -1 answer, like we did here. Okay. So all we need to do is graph. So we're at -1. Well, let's use red. So we're at -1, and you can use our points, which is 0.5 or 1.5, and again you can use slope-intercept form. So we have m, and our b is -1, and we have to go down 1, right 2, down 1, right 2. As you can see, we flipped over that x-axis. Okay, now we're going to move on to our next one. So our negative sign for this is applied to the x on the inside. So what we're going to do is we're going to take our x values, -1, 0, and 1, and we're going to plug them into a negative x. So we're plugging in our negative sign and then our x's. So a -1 makes a positive, 0 stays 0, and 1 becomes -1. Okay, so now that we have our x's, we can plug those in, and we get 1 times 1/2 is 1/2, 1/2 plus 1 is 1.5. We plug in 0, we get 1. And then when we plug in -1, we get 0.5. Okay, now let's compare that to our parent function. Parent function was above, so we were at 1, and we went up 1, right 2, up 1, right 2, and our y-intercept was 1. And now for this one, we have to graph our x and our negative x f of x. So we are at -1 and we go to 1. We're at, oh, sorry guys. We are at 1 and we go to 1.5. We're at 0 and we're at 1. See how we have the same y-intercept as the parent function? That means we're doing something right. So now we're at that. And we are drawing our line. See, you can tell it reflects over the y-axis because of the y-intercept being the same. And if we're describing, we're saying reflect on y-axis. Okay, like the previous one, we can rewrite a function. So I'm going to show you how to do that. We have our parent function as 1/2 x plus 1, but here we're doing a negative x. Okay, so negative times a positive always makes a negative. So now we have a -1/2 x plus 1, and this is our new function. You can tell if this is b, we are still at 1, and we went down 1, right 2, down 1, right 2. Alright, next page. So we have this example next, -4x minus 2. And we'll run through this one together, and then I'll have you guys do example 3 on your own. We're going to talk about our steps. Okay, so our negative's on the outside, so instantly we know it's a reflect over the x-axis. And we're plugging in our points to our parent function. That would give us a 4 minus 2, which is 2. Then we get a -2, and then we get 1 times -4, which is -4 minus 2 is -6. And that's our first step. Now we're on to our negative f of x. And because this is our f of x answers, all we have to do is just do -2, +2, and +6. Okay, so we can plot our points. We're at 1, -1, 2, -1, 2, 0, -2, and 1, -6. And this actually matches up with our slope. If our slope is -4, we go down 1, 2, 3, 4, and then we go right 1. We're at 2 and 6. So because we know it's reflect over the x-axis, it's going to reflect right where it crosses our x-axis. So now we're on to our new function. We go to -1, -2. We go to 0, 2, and we go to 1, 6. And though that is hard to tell, these graphs would have crossed right around here. I'm going to try to redraw those lines. We're going to -2. We're at -2. Let's draw a better Okay, that's close to being better. And then we have -1, -2, 0, 2, 1, 6. And we should really be reflecting on the x-axis. So now we have -x. And that's on the inside, so we know that's going to reflect over the y-axis. So we have our parent function. I'm going to graph that. That's still this section up here. So we're at -2, -6, and +2. See, our y-intercept is at -2, so we know we're going to reflect at that point. So they want us to do our first step is to make all of our x's negative. So -1 times negative will give us 1. 0 stays 0, and 1 becomes -1. Now we plug it into our parent function, doing -4 times 1 minus 2. And that's -4 minus 2 is -6. We plug in 0, we get -2, we plug in -1, and we get a +2. So let's go ahead and write this in. We're using these x values and these f of x or y values. So we're at -1, -6, 0, -2. See how they share the same y-intercept? And we're at 1, 2. We draw this. And you can also look at our points. They're the equivalent distance from the x-axis. So this is 1 unit, and this is also 1 unit. It's just on the opposite side. So while you're doing example 3, graph this. And label it as your parent function. And then remember, the negative on the outside is the x-axis, the negative on the inside is the y-axis. Okay, so you can, 1, make your table. So that's x with -1, 0, and 1. And then you can put it in with f of x, which is our normal. And then you're going to put it in with negative f of x. Okay, so you can make the table, or you can go ahead and apply that negative sign on the outside of our function, and it becomes -3x minus 2. And now with that, you can plug in your points, or you can use b as -2 and m as -3. So those are your options. You can use a table, that's fine, or you can just graph using point slope form. Okay, and that is all we have for reflections.